Assalamualaikum and greetings everyone. Today's topic is on Green's theorem in XY plane. But before we go to Green's theorem, let's look at some of the terms that we need to know. The first term is closed curve. We know about closed curve. Closed curve is a curve where you start and stops at the same point. Another term that you need to know is simple curve. So a curve C is said to be simple if it does not intersect itself between its endpoint. So here we have four curves. Curve A is not closed and it is not simple because we have intersection there. Curve B is closed, but again it is not simple because we have an intersection between the endpoints of the curve. Curve C is simple but not closed. Curve C is simple and closed. Another term that we need to know is positive orientation. So for positive orientation, with respect to region R, is if the region enclosed by C stays on the left of C. So for a simple closed curve, it will be a boundary to a region. So here we have a simple closed curve. It will be the boundary of a region. And the orientation of the simple closed curve is called positive orientation if the region enclosed by C stays on the left of C all the time. So in other words, the orientation should be in anti-clockwise direction. Anti-clockwise direction. Because then if you can picture yourself walking on the curve using this orientation, the region will always be on your left hand side. So that is called positive orientation. Another one is, that's it. Okay, so now we can go straight to the Green's theorem. There is a theorem known as the Green's theorem, which can be used to find the value of line integral for a simple closed curve on a plane. Okay, so remember, Green's theorem can only be used for curve on the XY plane, and the curve is simple and closed. Okay, let R be a simply connected region whose boundary is a simple, closed, piecewise smooth curve oriented counterclockwise. If Pxy and Qxy, those are the components of vector field F. If P and Q are continuous and have continuous first partial derivatives on some open set containing R, then, so here we have, this is really f dot dr. This is really work, which is equal to f dot dr over closed curve C. So work is equal to f dot dr, and if we simplify this, what we get is pxy dx plus qxy dy, because f is a vector field on a xy plane, so it has x component, which is p, and the y component, which is q. So according to the Green's theorem, f dot dr integrate over closed curve C is equal to partial q partial x minus partial p partial y integrate over region R. So region R here is the region bounded by the simple closed curve C in an anti-clockwise direction. So this is called Green's theorem. Okay, for an example, I'm going to save that in our next video. Thank you.